Welcome back to EduHub Academia, the Education for a Better Future platform. This is lecture number 9 in the World of Physics course, and today we will talk about sound. Let's start by defining sound as a form of mechanical energy that results from the vibration of particles in a medium, typically air. What about the nature of sound? First of all, sound needs a medium to travel from one place to another, unlike light that can travel in vacuum. When an object vibrates, it creates sound waves that propagate, that travel through the surrounding medium. Sound waves are longitudinal waves and not transversal, meaning the particles vibrate in a parallel direction to the propagation of the wave itself. Also, the sound wave consists of compressions, C, which are the regions of high pressure, and rarefactions, R, which are the regions of low pressure. You can see in the diagram below comparison between a transverse wave and longitudinal wave sound. Sound is a set of compressions and rarefactions where particles condense or disperse. And of course, these are in successive pattern. Now, how does sound reach us? First of all, when an object creates vibrations or disturbances in the air, it produces sound waves that travel outward in all directions. When those vibrations, when sound waves reach our ears, they cause our eardrums to vibrate. The vibrations of the eardrum are then transmitted through a series of small bones in the middle ear to the cochlea in the inner ear. The cochlea is filled with fluid and contains tiny hair cells that convert the vibrations into electrical signals. Now, these electrical signals are then sent to the brain via the auditory nerve, where they are processed and interpreted as sound. Now, what are some basic characteristics of sound wave? First of all, we'll talk about the amplitude of a sound wave. And this is the magnitude or intensity of the wave, and it is related to the loudness, or basically to the volume of sound. It is measured in decibels, with higher amplitudes representing louder sounds. Now, this is the amplitude A, as you can see here. Wavelength, on the other hand, lambda, measured in meters, is the distance between two consecutive points that are in phase. And what do we mean by in phase? We mean either two compressions, consecutive compressions, or two consecutive rarefactions. This is called the wavelength. The wavelength is inversely related to the frequency of the sound, meaning the higher frequency sounds have shorter wavelength and vice versa. The frequency. The frequency of a sound wave refers to the number of cycles or vibrations per second and is measured in hertz. It determines the pitch of the sound, with higher frequencies corresponding to higher pitched sounds and lower frequencies corresponding to lower pitched sounds. Finally, the speed of a sound wave, meter per second. It determines how fast the wave can travel in a specific medium. Now, what's the relationship relationship between those three basic terms, namely the speed, the frequency, and the wavelength, we say speed v is equal to the product of wavelength lambda times f, the frequency. Using this triangle, we can find any term we want, like frequency equals speed over wavelength, wavelength equals speed over frequency, and speed equals wavelength times frequency. Thank you very much. Looking forward to meeting you in the next lecture.